Welcome back to Raspberry on the Boat 11. You see some AIS data here. We took this last time from our Daisy head and we forwarded it to our own MarineTraffic station. Unfortunately, we have no own AIS information as the Daisy is just a receiving unit. We have GPS though, so we have a position and NMEA-based GPS information, but our Daisy head is just a receiver, so we can't forward this data somewhere. But what we could do is create our own AIS Class B NMEA sentence. We can take the GPS information, maybe we delay this a little bit, so that's not too many information. We create our own sentence and we could forward this to MarineTraffic. So even though we don't have a transceiver, we just have a receiver, we could create our own AIS sentence. But it's not that easy, as I found out. So let's start. So the first thing you should download is this document. This is from the International Telecommunication Union, and it's a great recommendation how the AIS data should be generated. It explains the different messages and how the encoding of each message should be done. And we will use this during this tutorial, and you will find it on the link given. Next is to take a look at the decoder. There are a lot of online decoders available. I prefer this one because this one has already a lot of examples given. So you see all these entries, you can decode them at once. We will do this in a second. Note the beginning, the AI VDM or VDO. VDM is for a message which is about another vessel, and if you see the O at the end, it's your own vessel. So when you want to decode a sentence, you just press decode and you paste the sentence before. But if you just want to see the examples here, just press decode immediately and you get all the different reports. And there are a lot of reports in for different messages. So message 1, 2, and 3 is for position reports of Class A ships. And we will take a look at message 18. Message 18 is the position report for Class B ships, and that's exactly what we want to generate. So there's also this example sentence we can use and try to rebuild the sentence to see if our algorithm is working. You see that there are a lot of different attributes in which needs to be filled, some manually like the MMSI, so that's something you have to paste, but there are also some variables like position. Here's another decoder. They are all more or less the same, but this one has the advantage of all these examples given. So let's take one sentence I received a second ago and let's take a look. We already spoke about the beginning, so that's always an AIS message, either with the M or the O. The explanation mark starts the message, so that's necessary. At the end, there's the checksum. We did the calculation of the checksum already in another tutorial. The checksum is done without the explanation mark at the beginning. And then we have this part here. This is readable for humans. And you see the 1, which means it's just one message and it's the only message. So first of one. And then this A is for the frequency. So if this is the one or the other frequency, but you can keep this empty also. This one is the payload, and that's what we need to encode. But maybe we start with the first easy example just to create the checksum. So I will create a function node and paste the complete sentence. We remove the exclamation mark at the beginning because the checksum is calculated later on. And I just call the sentence now, and I will just take the beginning of the sentence and then the part afterwards. Let's let's call this payload or something of the sentence. So that's what the main part for today, which we need to generate, but we take this payload first to see if everything is working. And then there is the end of the sentence. So there is last information we need to send. And I remove the checksum. As I said, we need to do the checksum at the end. Oh, I did a mistake, but let's first make the complete sentence. So we make a string at sentence plus the payload sentence plus the end of the sentence. But I need to join this one. So this is and oh, there is a mistake as well. So now this should work. When we place a debug node and an inject node, we can check if the sentence is now created. Of course, this is quite easy up to now because we just did a string and we combined the string again. But let's take the NMEA checksum already. We did this in another tutorial. I will come to this, but let's take this as a sub node and we deploy it and we start it again. And now we get the checksum. And it's again the exclamation mark at the beginning and the 70 at the end. And if we paste this into our decoder, we get all the data back. So this checksum subflow is something we did in tutorial number 9. Let's take a look into the subflow, and there's just a simple function node, and this function node has an input and it takes each character of the input with an XOR function, and then it is converted to hexadecimal. And then I did two changes since to our last tutorial. I changed all letters to capital letters, and I changed the dollar symbol to the exclamation mark symbol. But that's all, and we did this already chapter 9, the remaining part. Let's go back to this decoder, and we try to find message 18 again. So the example for the class B position report, that's the only message we want to create, the 18. We will copy this one and just clear the text box and do it again. So we just have this message now. Let's try to rebuild this example. If we get this, we can do any sentence. So I did prepare something. I kept the beginning and the end. That's the same also for this example. But I created a constants describing all the different parameters of this sentence. Take a look at the longitude. I did split this in two parts, in degrees and minutes, and same for the latitude. The reason is that there are several formats available: decimal degree, then there is a degree and minutes, and then there is degree, minutes, and seconds. All three are common, and they use degree and minutes. The GPS is using decimal degree, so we need to convert this later. In this case, we start with two separated items. Later on, we will convert this to one. Well, now we need this document I mentioned at the beginning and look for chapter 316, so message 18, standard class B equipment position report. You will find all the parameters here as well, which we saw in the decoder, but here you see also the number of bits for each parameter. We need to know how many bits we have for encoding. On the right column, you will also see what's the LSB of each bit. So for example, for the longitude, we have 1/10,000th of an angle per bit, and that's necessary to know. So we have 168 bits for the payload. Maybe one comment regarding the last parameter, the communication state. There is a default for class B, this one in binary, and we will take this one as well and not use a specific one. So, and I already did some comments in my file so that I know what is the default, how many bits do we have, so that we have it easier not to switch between the document and this one for encoding. So before we can convert this to binary, we have to correct a few parameters. So the speed over ground is given in 1/10 of a knot, so we multiply this by 10. Same for the course over ground which goes not only to 360 but to 3599. Longitude is given in 1/10,000th of a minute, so we multiply this now by 60 the degree to get it to minutes, and by 10,000 to get it to 1/10,000th. And the minutes we got, we just add them and we multiply them only with 10,000 because they are already in minutes. Same for latitude, and then we have already the right format. Okay, now we need to convert this to a binary format. I did a function note here to explain how to convert a number. So I have a decimal 8 and I want to convert this to binary, and this is possible as a string. So I take the decimal and then a method which is called toString, and you need to specify which format, and we take 2 for binary. So you can also use hex with 16. We did this already in another tutorial. And when we deploy this, we get the string of the binary for 8. As you can see, when I change this to 2, and I do it again, we get a 1, 0. So we don't get leading zeros, but we need them for our project. So we need to set this to a specific length. Let's assume we want to have a length of let's say 5 bits. Then we do something very simple. We take a while loop. We test if the length of the decimal is still smaller than our target, so the 5 bits. And if this is the case, we simply do a string add. We simply add the decimal 0 to our existing, so a leading 0 to our decimal string. So when we deploy this, we get still a 1, 0. Okay, I did a mistake because the payload is still the first one. So let's put this to decimal, and we do at the end the handover to the payload. Just do it again, and you see now it's working. So we get a length of 5 bits, even though we just have leading zeros here. And we can, of course, also at a longer sentence, we will have this later on, 27 bits for the latitude, and higher bits we can also put higher numbers, of course. So that's how to convert this to binary. And I did already integrate this into our function node as a function, by the way. So I created a binary function that's easier instead of just doing this all the time again. And I took all the parameters. So my function has the input and the number of bits. And I took the ID with 6 bits, the repeat with 2 bits, and so on, MSI with 30 bits, and added them to a full binary sentence, and when we deploy this, we get the checksum plus this binary sentence. However, we need to convert this to chars. So let's do a little exercise. I have defined an A with 65, and we get the 65, so nothing special. And now I want to convert the 65 because this is the ASCII format to the real character. And there's a method which is called string from char code. And when I enter the number 65, so my variable A, I get the A as a character. Well, that's already good, but we don't get a decimal value, we get a binary value. So the first thing we need to do is to convert this, and it's a string. We need to convert this binary string with parseInt method back to a decimal value. We tell them our variable A and that it's binary with 2, and we get back the decimal value, and we still can use this function. So this was a binary 65. Now I have another example. I have 2 65s in a row, so a word, but we want to take the first 8 characters and the next 8 characters. So we create a while loop, and our target is to do this until the complete string is covered, so until the length of A, which is our string. And now we will take the first 8 bits, or the first 8 characters, but this is just 0 and 1, it's a binary, and we take these 8 bits, so this is I and I plus 8 for the first 8 characters, and now these characters are converted back to the integer what we did before, but now in a while loop for each 8 characters. Then we have to add, of course, 8 to our variable I, so that the while loop will not be an endless loop. And at the end, we also want to take each part of our substring, so each substring, and convert this substring to a character. So that's only a temporary variable for us now to create our complete string. Okay, and we need, of course, to extend our sentence step by step, or our variable a. And let's try this out. And I made a mistake, as you can see. So first of all, there's the old bit field in, and also some other issues. So there was one mistake, that I didn't take the temporary variable for the pass, but we also need to use a new variable here, which we call a out maybe, to separate this from our origin a. And as a out is already necessary to edit in the first call, we define this as an empty string at the beginning. Another try, and let's see, and we got AA, so working. Yeah, but of course that would be too easy now. AIS is using 6-bit ASCII, means you don't have 8 bits, you just have 6 bits, and that gives a shift in the definition. So a normal decimal 65A is a 1 here. And that's not all, it's also using payload armoring. So the payload is not a real char set, it is a armoring of chars, and this gives an offset of 48, or even 48 plus 8, so 56, depends on the decimal value. I did consider this already, and you can see the result. So I take 6-bit fields, it's the same code but 6 bits, and now I need to add 8 if it's above 39, so if it's 40 or higher, and always 48 to the value before I convert this to a character. That is necessary for the payload armoring. And now we can create the full sentence. So the sentence is already the beginning plus our payload. We did this already. And now we need to add the end of our sentence. And then we should have our complete AIS NMEA message. Let's give it a try. And of course, we did an error. Yeah, our new variable I is not defined. So this is necessary for our loop. So just let's add the 0 here, start again, and here we go. That's our AIS sentence. And this is exactly the same sentence what we found here. We can just paste it, and you see it's exactly the same. That is our test sentence, which we used from this page. And when we compare these two, they are exactly the same. If you go to this page, you will find it here. That's the sentence which we used also as an example here. All right, that's it already. I did a little bit more afterwards. So I took my GPS information, I took out a specific sentence, and I took out the latitude. Also the poles are necessary, by the way. We didn't cover this up to now. I will mention this in a second. And I also took speed and the track from the GPS. And I forward all this data to my sentence node, and I put a delay in it. So I took 5 per minute, but let's take 6. So every 10 seconds we get a message currently. And this is exactly our code now, what is in there with the checksum and so on. The only difference is that I consider the poles. So there is the longitude and latitude is in a decimal value now, and I consider this as a pole. So if the pole is west, I take 2 to the power of 28 or 27. Longitude and latitude has 28 or 27 bits, -1. And then I subtract longitude or latitude when it's south. That's necessary because it's -180 to +180 degrees, which is given. But that's all. The rest is the same. And you see every 10 seconds I get my AIS information created. Yeah, so that's our AIS creation. It was more complicated than I thought. I still did this as a tutorial for you. Hope some of you find it helpful. We can use this to create our own position and forward this to MarineTraffic, but this is of course only allowed if you have your own MMSI. Yeah, that was my last winter project for Raspberry on a boat. I have a last project left, which is the MPU 9250, which is also maybe interesting for the boat because you can have your heel and pitch. So if you're interested in that, please subscribe now, and I see you maybe on the water. Bye bye.